Hey everyone, we're going to learn our second method for solving systems of equations. And this method is going to be the substitution method. And it's exactly what it sounds like. We're going to take one equation and substitute it into the other equation to find either x or y or whatever variables we're working with. Usually we're going to be using x and y's. And so there's a few steps that we want to follow. So I'm going to go through them real quickly, and then as we do an example or two, hopefully you'll see where these steps come into play. So again, we're going to use the substitution method. In order to do that, we need to solve one equation for one of the variables if it's not already done so. We'll eventually talk about which method is best. And so if one of the equations is already solved for a variable like x equals or y equals, substitution might be the best method to use. But we can always solve for one of the equations. And the key is we're going to choose an easy one to solve, and you'll see what I mean by that in our example. Once you solve, you're going to then substitute, right? That's why it's called the substitution method. We're going to substitute that equation that we created in one or found in one into the other equation. This, in essence, eliminates one of the two variables. Then, because we eliminated one of the two variables, we can solve this new equation for the remaining variable. This is going to give us one of the two values we look for. Remember, a solution is an x and a y. So this solving will give us one of the two. Once we have that, we can use that information to find the other unknown variable. And we're going to substitute that back into our equation from 1. Just like we did with graphing, we want to check our answer, make sure it works for both equations, and then we write our answer as an ordered pair. Remember, we're always looking for an ordered pair unless it specifically says just x or just y. But typically we're always going to look for an x and a y. So with that, we're going to solve, substitute, check and write. So let's look at our first example. Here's our system of equations. We have 3x plus 4y equals negative 2. And we have negative 2x plus y equals 5. Now we could graph these and find where they intersect, but we don't have graph paper. And 2, this equation might be a little difficult to graph. So we're going to use the substitution method. Now, let's look at our two equations. 3x plus 4y equals negative 2. Negative 2x plus y equals 5. Think about what equation is going to be easier to work with. If we look at our top equation, I have coefficients of 3 and 4. In equation 2, I have coefficients of negative 2 and 1. Wherever you see a 1, that's going to be the equation you want to work with. Okay? So our first step is we're going to solve negative 2x plus y equals 5, and we're going to solve for y. Now to solve for y, we just add 2x to both sides. So our equation is 2x plus 5. Now, remember, an equation is like a scale. It's balanced. Wherever there's a y, I could replace it with a 2x plus 5, and it stays balanced. Wherever I see a 2x plus 5, I could replace it with a y. They are the same thing, right? That's what the equal sign means. So that's step 1. Step 2, we're going to look at our first equation, 3x plus 4y equals negative 2, and notice that this y and this y are the same, right? Because a system of equations, the x and y are the same for both, this y is equal to the y in our first equation. And so what we're going to do is we're going to substitute that y, but we're going to substitute it with what it's equal. Y equals 2x plus 5. right? This comes from here. That's where that comes from. They are the same thing. This y and this y are the same. And this is going to equal -2. So that's step 2. We substitute our equation that we found in 1 into the other equation. Step 3 is going to be solve that equation. So I'm going to solve this equation. To solve, we need to distribute. So 4 times 2x is 8x, right? 4 times 5 is 20. That equals -2. This gives us 11x plus 20 equals -2. Subtract 20. 11x equals -22. Dividing by 11, x equals -2. So we have half our answer. We found x. Now we need to find y. And so step 4, we need to substitute. We know x equals -2. We're going to substitute that back into for y. So y equals 2 times -2 plus 5, -4 plus 5, and so we get 1. And so our answer, when all is said and done, is our x value is -2, our y value is +1. And so we can check to make sure that works. Plug it into our original equations. -2, I'm just going to do some mental math, -2 times 3 is -6, plus 1 times 4 gives me -2. First equation works. Equation 2, I'm going to plug it in. -2 times -2 gives me a +4, plus 1 for my y, I get 5. It works. This is our answer. Again, if we were to graph these two equations, our lines would intersect at -2, 1. This is another method that gets us to that same answer. Looking at example 2, you can try this on your own, pause the video, and then see if you get to the same answer. Notice in this one, x is already solved for. So step 1, we don't have to do anything. So x equals 3y minus 2. 2, we're going to substitute wherever we see an x in our first equation with what it's equal to. 5y minus 2. I'm going to substitute what x equals. 3y minus 2. And this will equal -1. Now we solving the equation. 5y, distribute. Don't forget 2 negatives make a positive. Combine like terms. Add, subtract to get variable by itself. Right, here I subtracted 4. And then last step is to divide by -1. So y equals 5. Again, we're only halfway done. I'm going to take the fact that y equals 5. So x will equal 3 times y is 5 plus minus 2. 15 minus 2 equals 13. The solution to this system, which is step 5, is 13. Be careful again, here we solved for y first and x second. So x is 13, my y value is 5. The ordered pair is 13, 5. Let's plug in to make sure it works. Here's our check. I'll use red. 5 times 5 minus 2 times 13. Does that equal -1? That's 25 minus 26. Check. Also, I need to check to make sure that 13, that's my x value, is equal to 3 times 5 minus 2. Well, this is 15 minus 2, and that in fact does equal 13. So that's a check. Here is our answer, 13.5. If we were to graph these two equations, the point of intersection would be 13.5. 13.5 makes both of these equations true. So this is how you use substitution to solve system of equations. Going through again, we want to solve one of the equations for one of the variables, substitute that equation into the other equation, solve for the remaining variable, substitute to find the other unknown variable, and then we always want to check our answer. That's what's beautiful about this. You can check your answers to make sure it is correct. Hope that helps.